This video introduces the concepts of Agentic AI, the multi-context protocol, and the role of skills in modern bioinformatics. We will explore how these technologies are advancing research within the Mayan Lab. In this video, we will cover the definition and importance of Agentic AI, the anatomy of an agent, the mechanics of tool calling, the use of skills, the multi-context protocol, and the future outlook toward AGI. The development of AI has occurred in layers, building from classical methods to neural networks and generative models. We are now entering the era of Agentic AI, where systems can plan, use tools, and operate autonomously to complete multi-step tasks. Agentic AI allows users to define objectives that an AI brain pursues through autonomous execution and tool use. This approach enables complex workflow automation, seamless integration with external data, and scalable operational intelligence. The CFDE Workbench Assistant provides a chat-based interface that leverages the OpenAI API and registered workflows to help users access and execute tools created by various data coordination centers. For example, a user can ask the assistant to find tissue expression for a specific gene. The system retrieves data from the GTEx portal, processes it into z-scores, and visualizes the results as a bar plot. The assistant can also query specific knowledge about common fund programs, such as the Acute to Chronic Pain Signatures DCC, providing summaries and direct links to relevant program homepages. Furthermore, the assistant can guide users through data integration. Here, it outlines a practical plan for integrating SendNet and A2CPS data, following the CFDE crosscut metadata model. The anatomy of an agentic AI includes perception to monitor state, cognition for reasoning and planning, action for tool execution, and learning for iterative self-improvement. The CFDE chatbot functions by taking a user query, processing it through an LLM, and connecting to various tools and the CFDE Workbench MCP server to return relevant information. A Model Context Protocol server is an open standard that allows AI assistants to securely use external tools and data, simplifying integration by exposing search, analysis, and workflows through a single interface. Deep Dive 2 leverages the CFDE Workbench MCP server to define specialized tools, which are simple functions that allow the LLM to generate high-quality, evidence-based summaries. The CFDE chatbot utilizes a variety of tools, ranging from GlyGen and GTEx expression queries to Lynx L1000 searches and CRISPR knockout signature analysis. The CFDE Workbench MCP server organizes its capabilities into documentation, outreach, search, and statistics, ensuring programmatic access to comprehensive biomedical content. Looking forward, the architecture will expand to include multiple MCP servers, allowing the LLM to access an even broader array of workflows, tools, and summaries to assist researchers. To develop an MCP tool, like this GTEx API caller, you must define a clear description of the tool's purpose and an input schema that specifies the required arguments. This enables the LLM to intelligently select and utilize the tool. Integrating these tools for an LLM is straightforward. You simply provide the server configuration, including the label, description, and URL, which allows the AI to connect seamlessly to the defined MCP services. To get started with your own implementation, we recommend exploring these GitHub repositories. They provide templates and established project structures that help you build your own MCP servers quickly. Beyond MCP servers, there is also the concept of skills, which are alternative ways to extend agent functionality. They encapsulate multi-step operations and workflows and can be easily shared across multiple agents. While MCP servers provide a standardized interface to external tools and data, skills act as goal-oriented workflows. In essence, the MCP server provides the capabilities, and the skill knows how to orchestrate them to accomplish a specific task. You can find more detailed examples of how to build and implement skills by visiting these GitHub repositories, which offer practical guides for creating effective, agent-ready workflows. As we look toward the future, the concept of artificial general intelligence, or AGI, serves as a framework for where these technologies are heading, moving from narrow, specialized tools toward autonomous systems capable of human-level reasoning and broad domain application. Finally, we would like to acknowledge the dedicated team at the Mayan Laboratory, whose hard work and contributions made this research possible. Thank you for following along with this video.